today to yet another opportunity to hold a class on place. And in today's class, we shall be talking about understanding, or we want to solve a simple question that will help us have a better understanding of what speed is. Remember, we agreed in our previous class that speed is the rate of change of distance with time. Distance divided by time gives us speed. We went further to talk about what we call uniform speed. When we explain or talk about uniform speed, we are talking about the distance that is covered at an equal time interval, no matter how small the difference between them is. The consistency in this, for example, if you cover 20 meters in 5 seconds, it means that the speed will be what? The speed will be 20 meters divided by 5 seconds, which will give us 4 meters per second. If in another instance we cover 40 meters in 10 seconds, 40 divided by 10 will still give us 4 meters per second. That is what we mean uniform. No matter how small the interval is, they will have a similar value. But in today's class, beyond that, we want to quickly look at what we call average speed. And I told you that average speed has to do with the total distance covered all over the total time taken. For example, you want to move from a location A to location B, and the distance between location A to B is 100 meters. And it took you, maybe with the help of your stopwatch, to cover a distance between A and B in 5 seconds. It means that the average speed will be the 100 meters, which is the total distance covered, divided by the 5 seconds that is the time taken to cover the distance. And whatever value we have at that particular distance is our average speed. Now look at average speed in terms of initial velocity and final velocity. When you look at the two of them, if you want to find the average, you will now in this case need to add both the initial value to the final value. In this case, your u plus v divided by 2 gives you average speed. Is that clear? Now, in today's class, we just want to solve a question. This question, I'll read out the question, or sorry, I'll write out the question, and then from the question, we will try to solve it. Now, the question is, a body at rest is given, the body at rest is given an initial uniform acceleration of 8.0 meters per second for 30 seconds. After which the acceleration is reduced. To 5.0 meters per second squared for the next 20 seconds. The body maintains the speed for 60 seconds. After which it is brought to rest in 20 seconds. Now, we are required to draw the velocity time graph. Using the above information. Then we also ask to calculate the maximum speed attained during the motion. average retardation, as the body is being, as the body is being brought to rest, brought to rest. And number three, the total distance traveled during the first 50 seconds. And number four, we are asked to find the average speed. Average speed during the 50 seconds interval of time. Now, this is the question we have, and we want to attempt solving this question. But before we solve the question, let us quickly read through the question. It says, a body at rest is given an initial uniform acceleration of 8.0 meters per second squared for 30 seconds, after which the acceleration is reduced to 5 meters per second squared for the next 20 seconds. The body maintains the speed for 60 seconds, after which it is brought to rest in 20 seconds. Now, required. Draw the velocity time graph using the above information. 2. We have to use the graph from the graph, determine the maximum speed attained during the motion. 2. The average retardation as the body is being brought to rest. 3. The total distance traveled during the first 50 seconds. And 4. The average speed during the 50 seconds interval of time. Now, first of all, we have to get a sketch. So let us remember that when we talk about speed acceleration, and uniform motions, we agree that there are three graphs involved. We have the distance time graph, whose slope gives us speed, the velocity time graph, whose slope gives us velocity, and then the displacement time graph, whose slope gives us velocity, and the velocity time graph, whose slope gives us acceleration. So first of all, we have to draw the velocity time graph for this question. So we take this on our book, and then this is the vertical component, and this is the horizontal component, and this is our origin. The question says velocity time graph. Velocity is measured in meters per second, and our time is measured in seconds. So the first thing we need to do is to interpret the question. This is origin, this is the rest point. So the body moving from rest starts from here. And we are told that it's accelerated with an initial velocity, uniform acceleration of 8 meters per second. We got to this point for 8.0 meters per second in 30 seconds. So that means the time taken here is 30. We are told after this, we say for 30 seconds, after which the acceleration is reduced to 5. Now this is 30 and it dropped to 5. Now at the point it dropped to 5, this one is now 5 meters per second. It has a negative sign, telling you that there is a deceleration, there is a loss in speed of the body. And this took 20 seconds. Let me make the diagram easy. So this is minus 5.0 meters per second squared. And this took 20 seconds. Now I cannot write 20 like I've done here. I will add the 20 to 30 to get 50. So I have 50 here. Now after this, the question says the body maintains the speed. At what speed? At the acceleration of 5 meters per second speed, it's maintaining for the next 60 seconds. So let's take this for 60 seconds. If I add 60 to 50, I have 110. Now, when the brakes were applied, now said that after which it is brought to rest in the next 20 seconds. Brakes were applied like this, and the body came to rest in the next 20 seconds. I'll add 20 to 110 to have my 130. Now I have gotten this shape. I want to work with this shape. So how do do I make this shape easy? If you look at it, I have one, two, three, four divisions on this diagram. I can decide otherwise. I can decide to make it one, two, three, four, five. I'll see how far. If I look at it first, let me label it for easy. Let's call this point A, this point B, this point C, this point D, this point E, this point F, and this point G. Where this is our O. So in this diagram, I have OAG, which is a triangle. I have ABFG, which if you look at it from this direction, is a trapezoid. I have BCFEF or FE, which is a rectangle. And I have the other one CE, which is a triangle. The line CE is the guiding line, while the line OA is the accelerating line. Is that clear? So now, let us quickly agree that we have been able to put up the diagram. Now that we have a sketch that is correct, it will now help us to solve the question. It will now help us to do what? Solve the question. So for us to continue to solve this question, we need to also understand that acceleration is equal to velocity all over time. Velocity change over time. So since it was from rest, the initial velocity is already zero. So it has affected the height, so we can find our final velocity by saying that, okay, let me put it like v minus u all over t is equal to acceleration. We have a value for acceleration, we are looking for final velocity v. The initial velocity from the question we are told that body starts from rest, a body from rest is given that, so u is already zero. So and t in the first instance is 30 seconds. So I will now have v minus u is equal to a times t. V minus u is equal to a times t. Since u is 0, I will quickly say that v is equal to 8. And if v is equal to 8, then my v becomes equal to the acceleration of 8 multiplied by the time of 30 seconds, which gives you 240 meters per second. That is my value. That is the maximum speed that was attained at this point. Now, for convenience, when it was here, as it started coming down, it became initial and it became the final one because the acceleration dropped from 8 to 5. So for us to do that, we'll quickly come back here and then look at this. Remember, we got the value of this. The speed, the maximum speed here is 240 meters per second. We need to get at this point. So for us to get this point, we can call this point V1 and call this one V2. So for us to get this, there will be a change in acceleration. So we have A is equal to V2, the final minus V1. Now remember, here is 1, here is 2, but we already have another one. We already have them arranged in a way. So what do we do in this case? We have gotten our final velocity, the highest one is 240, and the time taken now will not be 30 seconds. It will be the difference between 30 and 50 because it was after 20 seconds that there was a deceleration. So I will now have C here, which gives me 240 minus B all over 20 is equal to what? What do I have as my A in the second instance? Remember the acceleration is 5. I will now have 5. So when I cross out, I have 240 minus V1 is equal to 100. 240 minus V1 is equal to 100. So by this, I will now have, I want to collect like this. I will have 240 minus 100 is equal to V1. Because the minus V1 crossing to the other side becomes a positive V1. And then the difference between the two will be 140 meters per second. That's the value at this point. When the acceleration drops to 5 meters per second, the speed drop also to 140 meters per second. We are making progress. Any question? Quickly, I said the acceleration is changed. Acceleration is changed with velocity per time. So I initial physics, I got 240. So 240 minus 1, sorry, V1, all over 20, which is the time it took you to decelerate in 5 meters per second. The difference between 50 and 30, I got 20. So cross multiplying, I have 240 minus V1 giving me equal, is being equal to 20 times 5, which is 100. And from here, I got my V1 as 140 meters per second. Now that we have gotten this, it is not left for us to subsolve the space I have because I want to keep the question. It's not enough. So then I now want to quickly look at the first part. We have gotten the maximum speed attempt. We have gotten the next question they asked us was the average retardation. Now, how do we get the average retardation? We have already gotten this. Let's look at this diagram. If you look at CED, it's a triangle. And normally the area of a triangle is supposed to be what? Half this times height. But in this instance, we are looking at it in terms of acceleration. So we have acceleration equals to final velocity minus initial velocity all over time. Final velocity minus initial velocity all over time. At the point C where the body is coming to rest, this point here is the initial velocity. So it was now from rest. So our initial becomes z. And so we got to this point. So the final is here. So when we have these two, what do we do? Look at the question. What do we now do? Remember that from here is 0, this is the height. So if we must get our velocity, we must be able to solve it in a way that the difference between the two of them will give us a negative answer. And in getting a negative answer, how do we get it? We look at the question again, considering this as our decelerating plane of length, we now have the final velocity minus initial velocity. But in this case, remember that the one that is coming down will be higher in value than the where we started from. So what do? We now make it look as if it is u minus v. As if it is u minus v over t. Because in this case, our u, which is here, and then our v is the highest value, because it's the final value. So what do we have there? We have our a to be equal to 0 minus, look at from here to here is our value. So what's the velocity at that point? Sorry, what's the velocity at this point? Velocity at this point is 140. And then the difference between this time and this time is 20. So I have 20. So A becomes equal to minus 140 divided by 20, which will give me 7 meters per second squared. I have gotten my A as minus 7 meters per second squared, but the question says average retardation. Remember the first reduction, therefore average retardation becomes equal to minus 5 plus minus 7, which gives you minus 14. Sorry, minus 12 meters per second. The second string divide by 2 because these are two values. So if I divide these by 2, I'll have my final answer at minus 6 meters per second squared. Is that clear? Now, if that is clear, the next thing we need to quickly look at is the total distance that is traveled. Please permit me to pick up the question. You see, the diagram is there to guide us. So quickly we look at this. Let's look at this quickly. The total distance traveled. The total distance traveled we look at in terms of 4 sections. Now, let's call this section 1, call this one section 2, call this one section 3, and this one section 4. So for us to get the total distance traveled, it will be total distance traveled will be equal to area of triangle OAG. Triangle OAG area of trapezoid base is OG, half OG multiplied by the height in the first instance is GA, sorry, GA, which gives us the half, the base is from here to here, which is half multiplied by 30 multiplied by the height is from here to the highest one, which is 240. And this gives you 15 times 240. And 15 times 240, I should be able to get an answer. So what do I have as an answer? Or let me make it easy because I don't want us to use calculator to waste time. So I have this and this. I have 0, 0. This and this is 12. This and this is 6 plus 1, 7. Divided by 2, which gives me 3,600 meters. That's the value for one. In the second portion, we have the trapezium. So we have area of trapezium AB, ABGF will be half of the sum of the parallel sides. If you look at the trapezium in this way, the parallel sides are AG and BF. AG plus BF more than their height. Their height is not like this. Their height is the difference between G and F. But we are looking at it this way. So G to F. And this gives us half into our AG is 240 because our BF is 140 and our height is 50 minus 30, which is 20. So what do we have then? We have half in 380 all by 20. And if I divide this out, I will have 190 times 20, which will give me 0, 0. This time this is 817. I've got the value for the first, I've got it for the second, I'll wait for it, which is the rectangle. So the third one is area of rectangle BCFD. The area of rectangle is less than 2. So if you look at this shape, this is the width and this is the height. So I now have BF multiplied by BF multiplied by this, which gives me 140 multiplied by, from here to there is 160. So I have 0, 0. This time this is 24. I have 4. This time this is 6 plus 8,400 meters. And then I look at the last, there's not a big section 4, which is area and triangle CBD. Which is called half ED multiplied by 7. That's the height. So I have half multiplied by 130 minus 130 is 20. Multiplied by the height is 140. 140. So I have here, as I have 10 times 140 is 1,100. So now in the 4 sections I have gotten the value. So quickly, total distance will now be equal to total distance total distance traveled. Because of the sum of the 4 individual distances we are going to have. First of all, 360 from section 1. So plus 1 4 sections. 4 sections. I now have this plus this plus this. Now add this, we have 00815 plus 14, which gives me 00271. So I have 17,000, oh, 17,200 meters, which is equivalent to 17.2 kilometers. That's the total distance I was traveling. Now, the last part of the question says we should find the average speed. Remember, this average speed is the ratio of the total distance traveled to kilometer times second. So, average speed becomes equal to total distance traveled divided by total speed. So in this case, our total distance traveled is 17,200 meters. And the total time from our stage is 130 seconds. 130 seconds. So by the time we divide 17,200 and 130, what we have to give us the average speed is very interesting.
Don't stop. Let's go. No, you are you. You stop on this one. Let me finish.